For over a century, one company built more locomotives than anyone on Earth. Baldwin Locomotive Works built 2,666 engines in a single year. It had a factory covering 616 acres, and it delivered tens of thousands of locomotives worldwide. Untouchable. Then a car company entered the locomotive business. Within 2 decades, General Motors did not just compete with America's greatest locomotive builder, it buried Baldwin. The last Baldwin locomotive rolled off the line on September 1, 1956. A flag was lowered for good. How a titan that stood for 130 years fell is a story far more ruthless than simple obsolescence. In the heart of Philadelphia, a small machine shop opened its doors in 1831. The founder, Matthias Baldwin, started out building and repairing stationary steam engines. By 1832, he had assembled his first experimental locomotive christened Old Ironsides. The machine's maiden run on the Philadelphia, Germantown, and Norristown Railroad drew crowds and caught the attention of railroad executives across the country. Demand followed quickly. By 1837, Baldwin's shop was turning out nearly 40 locomotives each year, a staggering figure for the era, when railroads were still carving their way across the American landscape. Baldwin's reputation grew on both sides of the Atlantic. Orders arrived not only from railroads in the United States, but also from Europe, South America, and Asia. Locomotives bearing the Baldwin name steamed through the English countryside, crossed Argentinian pampas, and hauled freight in India. Contemporary journals praised the company's engines for their sturdy design, reliability, and ease of repair, qualities that mattered to railroads operating far from major industrial centers. The company's ambition was matched by its technical inventiveness. Patents filed in the 1840s and the 1850s introduced new ways to balance cylinders, improve valve gear, and simplify maintenance. Each innovation was tested and refined in the bustling Philadelphia works, where blacksmiths, machinists, and engineers worked side by side. The factory floor echoed with the clang of hammers and the hiss of steam as teams built engines to order, each one tailored to the needs of its buyer, whether a Pennsylvania coal hauler or a Peruvian mountain railway. As the century turned, Baldwin's reach extended even further. The company's order books filled with names from every continent. By the dawn of the 20th century, Baldwin Locomotive Works had become more than a manufacturer. It was a symbol of American engineering, its locomotives carrying the promise of progress to every corner of the globe. The Eddystone plant stood as a monument to American industrial ambition. Spread across 616 acres just outside Philadelphia, this complex was more than a factory. It was a city of steel and steam, alive with movement day and night. In 1906 alone, Baldwin turned out 2,666 locomotives, each one a marvel of engineering, bound for railroads stretching from the Atlantic coast to the Pacific and far beyond. At full tilt, the plant's capacity soared past 3,000 locomotives a year, a figure unmatched by any rival on Earth. Inside Eddystone's sprawling workshops, thousands of workers filled every bay and aisle. Blacksmiths shaped red-hot steel, machinists carved precision parts, and teams of assemblers guided boilers and driving wheels into place with practiced efficiency. The scale was staggering. Rows of unfinished engines lined up like metal giants, waiting for their final fittings. Cranes rumbled overhead, shifting tons of iron from one end of the shop to the other. In the foundry, molten metal flowed into sand molds, casting the bones of the next generation of locomotives. The plant's rhythm echoed far beyond its walls. Baldwin's output powered the rise of North American railroads, moving coal, grain, and passengers across the continent. The sheer volume of production transformed the region's economy, providing steady work for more than 3,000 men and their families. Trains bearing the Baldwin name became symbols of progress, linking distant cities and opening new frontiers. For decades, the Eddystone Works defined what American manufacturing could achieve, an industrial colossus whose scale and productivity seemed limitless. In these years, Baldwin stood at the very center of the nation's growth, its locomotives fueling dreams of expansion and connection. Innovation was the backbone of Baldwin's rise. In the late 19th and early 20th centuries, the company's engineering teams filed a steady stream of patents, each one a new answer to the demands of a growing rail network. Among the most significant was the Vauclane compound system, granted U.S. Patent 1,100,563 in 1913. This design set high and low pressure cylinders on each side of the locomotive, smoothed out the engine's power, and simplified maintenance. The Vauclane patent became a signature feature, adopted by railroads that needed more efficient engines for longer and heavier trains. Baldwin's technical pedigree was tested on a national scale during World War I. As the United States entered the conflict, the Eddystone plant shifted into wartime production almost overnight. Between 1914 and 1918, Baldwin delivered 5,551 locomotives for the Allies, machines that hauled troops and supplies across France, Russia, and the Middle East. The assembly lines also turned out more than 6.5 million artillery shells, forging steel for the front lines as well as the railroads. Every corner of the plant was pressed into service, and the workforce swelled as machinists, welders, and laborers answered the call for war production. The war years revealed the full scope of Baldwin's capabilities. Teams of engineers solved new problems daily, adapting locomotive designs for harsh battlefield conditions and tight shipping deadlines. The company's reputation for reliability and innovation only deepened, as each engine that left Eddystone carried both technical ingenuity and a sense of national purpose. By the time the fighting ended, Baldwin was not just a builder of locomotives. It was a symbol of American industrial resolve, its patents and production records standing as proof of what a determined workforce could achieve under pressure. This culture of invention and service would shape every challenge Baldwin faced in the years ahead. In 1930, General Motors set its sights on the locomotive business. The company moved quickly, buying the Winton Engine Company in June and the Electro-Motive Corporation 6 months later. Those acquisitions were not just about expanding General Motors' portfolio. They gave the automaker direct access to the best diesel engine talent and the patents needed to challenge the steam giants. General Motors combined those assets to form the Electro-Motive Division, EMD, and poured resources into developing a new kind of locomotive engine. The breakthrough came in 1938 with the Model 567 diesel. Unlike earlier designs, the 567 was a two-stroke V-type engine, built specifically for railroad service. It delivered the horsepower railroads demanded, but with a fraction of the weight and maintenance headaches that came with steam. The engine's modular construction made repairs fast and easy. Entire power assemblies could be swapped out in hours instead of days. This was the technical edge General Motors needed. Backed by General Motors' deep pockets, EMD invested in mass production and standardized parts, a sharp contrast to the custom-built approach that defined the steam era. The company could now promise not just innovative technology, but rapid delivery and reliable after-sales support. By 1939, EMD was ready to show what its new diesel could do. The stage was set for a new kind of competition, one driven by efficiency, speed, and corporate muscle. With the Model 567 at its heart, General Motors Electro-Motive Division was poised to rewrite the rules of American railroading. In the spring of 1939, General Motors loaded its new FT diesel electric locomotive, 4 units strong and boasting 5,400 horsepower, onto the rails and sent it on an ambitious cross-country tour. The FT was not just a machine, it was a rolling sales pitch, engineered to win over even the most skeptical railroad executives. Over the course of several months, the FT demonstration train visited the yards and main lines of 20 major railroads, including Union Pacific, Santa Fe, and the Pennsylvania Railroad. At every stop, EMD's sales team invited railroad officials into the cab, handed them the throttle, and let the numbers do the talking. Fuel logs, maintenance records, and real-time performance data were laid out on the table. The FT hauled heavy freight over the Rockies, through the Midwest, and into the heart of the South, running day and night with minimal servicing. The technical advantages were clear, but General Motors' strategy went further. EMD offered a package deal, not just a locomotive, but a promise. Railroads could buy FT sets off the shelf, with rapid delivery guaranteed from stock. GMAC, the company's financial arm, made financing easy, so railroads could spread out payments, a sharp contrast to the old pay-upon-delivery model. Extended warranties and a nationwide parts exchange program sweetened the deal, ensuring that any breakdown could be fixed quickly, anywhere in the country. The FT's performance and the sales team's relentless push paid off. Railroad after railroad signed contracts, often for entire fleets. Within months, EMD's market share jumped. The FT Tour did not just sell locomotives, it rewrote the rules of the industry, leaving competitors scrambling to catch up. For Baldwin, the erosion of its customer base had begun, and the momentum was all on General Motors' side. Baldwin's first steps into diesel power were anything but smooth. The company's flagship experiment, the Centipede, was supposed to restore lost ground, a 2,500 horsepower behemoth designed to outpull anything on the rails. But in practice, it became a maintenance headache. Pennsylvania Railroad records show turbocharger failures and cylinder wear cropping up before the engines even hit 6,000 miles. Warranty claims swelled to $125,000, more than triple what EMD typically paid out for similar units. Instead of inspiring confidence, the Centipede's breakdowns only deepened doubts among railroad buyers. The problems were not limited to big road units. In the switching yards, Baldwin's VO1000 was billed as a workhorse, but a fire caused by a cracked fuel injector on Southern Railway's unit, number 1020, left a 30-car freight stranded and cost $12,000 in damages. Reports from the field described the VO1000 as underpowered and prone to downtime. Maintenance logs from the Baltimore and Ohio Railroad put the average miles between failures at just 8,200, far below EMD's GP7, which routinely doubled that figure. Inside Baldwin's boardroom, the company's leaders faced a stark choice. Younger engineers pushed for a full-scale diesel investment, citing GM's growing market share and the need for a modern production line. But the board, steeped in the traditions of steam and wary of risk, voted down major diesel spending in 1942. Instead, they clung to a conservative dividend policy, funneling 86% of the 1948 capital budget into steam upgrades and setting aside only a token amount for diesel research. The reasoning was simple. Steady dividends kept shareholders happy, even if it meant falling further behind. For Baldwin's engineers, each board vote felt like a door closing on the future. For the company's customers, every breakdown and missed delivery pushed them closer to GM's order book. The gap between innovation and inertia was growing wider with every passing year. At Eddystone, the war years brought both urgency and strain. The War Production Board's allocation orders dictated what metals arrived at the plant gates and in what quantities. Baldwin's steam contracts, deemed essential for military logistics, guaranteed a steady flow of steam-grade carbon steel. But the alloys needed for diesel engines, nickel, chromium, and molybdenum, were routed to naval suppliers and General Motors' diesel program. Internal memos from 1943 described prototype diesel tooling stalled by metal ration limits, forcing the company to keep steam lines running even as the market shifted under their feet. The impact landed hardest on the shop floor. Union newsletters from Local 8 tell the story in numbers. 12% of workers were laid off in 1949, swelling to 30% by 1954. Men who had spent decades assembling steam giants found themselves without work as new diesel orders failed to materialize. One worker put it simply, "We built 3,000 steam locomotives in our lifetimes. Now the machines that keep the plant alive are idle boxes on the floor." The sense of loss ran deeper than paychecks. Oral histories recorded at the Pennsylvania Historical Society capture the hush that settled over empty bays, the clang of hammers replaced by the hum of idle turbines. Some of the most skilled machinists left for General Motors' LaGrange plant, taking decades of experience with them. For the families of Eddystone, each round of layoffs meant another neighbor out of work, another row house dark at supper time. The pain of Baldwin's decline was measured not only in lost contracts, but in the lives upended by a company's slow unraveling. In the winter of 1950, Baldwin pinned its hopes on a merger with Lima-Hamilton, forming Baldwin-Lima-Hamilton, BLH. The plan was simple on paper. Combine Baldwin's heavy steel fabrication with Lima's lighter, high-speed passenger truck designs and split a $2.1 million budget for new diesel development. But the two engineering cultures clashed almost immediately. Baldwin's committees, steeped in hierarchy and tradition, struggled to communicate with Lima's collaborative teams. Decisions that once came down from senior engineers stalled in endless meetings, and the merged company spent $1.6 million of its development funds retooling steam lines instead of building new diesel test benches. The money ran out before a single competitive diesel prototype could leave the floor. While BLH's leadership wrestled with internal gridlock, another threat loomed from outside. The Department of Justice launched an antitrust investigation into General Motors Electro-Motive Division, scrutinizing the pricing clauses and exclusive supply deals that locked railroads into long-term contracts. Investigators pored over sales records and contract language, but after 2 years, the case was dismissed in 1954 for lack of evidence. General Motors' vertical integration and bundled warranties would remain untouched, and BLH was left to fight on, without legal relief or the capital to catch up. By the summer of 1956, the end was no longer in doubt. On September 1st, the Eddystone plant rolled out its final locomotive, number 70,001. The ceremony was brief but heavy with meaning. As the gold-painted engine left the shop, the Baldwin flag was lowered for the last time. Plant foreman William K. Hawthorne sounded the whistle, and the assembled workers stood in silence. After more than 130 years, the last chapter of Baldwin's story closed not with a bang, but with a quiet ritual that echoed through the empty bays. The era of steam and craft had given way to the age of mass production, and the greatest name in American locomotive building faded into memory. Today, corporate giants still decide who adapts and who disappears. The fate of Baldwin Locomotive Works is a reminder. Innovation waits for no one, and market power can silence even the most storied legacy. In every industry, the next disruption is already taking shape. The lesson endures: adapt boldly or risk vanishing without a trace. What industries do you see at a crossroads now? Let's discuss below.